Today we're going to look at another statistical measure, and what we're looking at today is the mean absolute deviation, usually abbreviated MAD or MAD. Sounds really hard, it's really not. It just has a lot of steps. It is the mean or average distance between individual pieces of data and the mean of the whole set of data. So let's talk about that just a little bit more. The steps that we use to find the MAD, we find the mean of the whole set of data. We should already know how to do that. We just average the numbers. Then step 2 is to find the difference between each piece of data and the mean of the whole set, and then find the mean of the differences. So really, we're finding an average, we're doing some subtraction, and we're finding another average. That's really truly all it is. It's just a lot of steps, and it sounds really confusing. And the reason it's called mean is, or absolute rather, is because when you find the differences, you're not necessarily carrying whether it's a positive or negative difference from the mean. You're simply carrying how far it is. So that's why we use the word absolute there. So let's take a look at an example. So here's our set of data. And the first thing we need to do is we need to find the mean of that set of data. Well, if I add all of those pieces of data together, I'm going to get 512. So 512 divided by, there's 8 pieces of data, so 512 divided by 8 is 64. The mean of the set of data is 64. So now what I need to do is I need to find the difference between 64 and each of those pieces of data. So I'm going to start by doing 64 minus 40, which is 14. And then I'm going to do the second piece of data. 64 minus 48 is 16. My next one, I'm going to do 64 minus 58. And when I do that, I'm going to get 6. And then I'm going to do 64 minus 60. And that's going to give me 4. And then I get over to where now I'm going to need to put the other pieces of data and subtract 64 from those rather than subtracting them from 64. And again, the reason I'm thinking about that is because I just want the absolute value of the differences. I don't really care whether it's negative or positive, so it's easier to just switch the order around. So I'm going to do 66 minus 60, which is 6, and I'm going to do 72 minus 66 minus 64 on the last one. I'm sorry about that. 66 minus 64, which is 2. And then I'm going to do 72 minus 64, which is 8. And then 80 minus 64, which is 16. And last but not least, 88 minus 64, which is 24. Again, the whole purpose there is to find how far away each piece of data is from the mean of the data. The mean of our data was 64. So notice what I'm doing. In every single case, I'm finding the difference between 64 and the original piece of data. And so now that I have those numbers, my differences are 14, 16, 6, 4, 2, 8, 16, and 24. I've got the differences, so my next step is to find the mean of those differences, and that's going to be my mean absolute deviation. So if I added together all 8 of those numbers, I'm going to get 100. 100 divided by 8, because there's 8 pieces of data, is 12 and 5/10. So the mean absolute deviation of that set of data is 12 and 5/10. What that really means is, on average, each piece of data is about 12 and a half away from the mean. Some of them are closer, some of them are further away. For example, our mean is 64. 66 is really close to that. 88, however, is a good bit farther. On average, each piece of data is 12 and a half away from the mean of the data. Now, the smaller the mean absolute deviation, then the lower of the variability of the data. In other words, the closer together it is. The larger the mean absolute deviation, the greater the variability of the data. In other words, the farther apart it is. So something to think about with that is let's say, for example, that you had two job offers. If you were basing your decision solely on the information about salary, not about whether you'd rather work in a pediatric office or Joe's Body Shop or whatever, if all you're basing it on is the money, which one would be a better choice for you? Well, looking at this, it certainly at first glance looks like community pediatrics is going to be a good choice because you're looking at a mean salary of $90,000, while at Joe's Body Shop, the mean is only $68,000. However, when you look at the mean absolute deviation, you're going to see that at community pediatrics, there's a whole lot more variability of the data. What that means is the people who are making the lowest amount of money and the people who are making the highest amount of money, those distances are pretty far apart. That's what having a large MAD means. That's what it means when you have a large mean absolute deviation. But when you look at Joe's Body Shop, the mean absolute deviation is only $3,750. What that means is there's not anybody that's making a ton of money, but there's also probably not anybody who's making just a very small amount of money because the mean absolute deviation is relatively small, meaning the salaries of the people who work there are all pretty close together. So if you had to look at this just based solely on how much you're likely to get paid, Joe's Body Shop is probably more of a sure thing because even though you might not get there's a possibility you could get paid more at community pediatrics, chances are you are going to do better at Joe's Body Shop because there's going to be a more consistent amount that each worker is going to be paid. Let's look at this in another context. Let's go back to our Student 1 and Student 2 grades that we've looked at before. Now, Student 1, we've looked at and we found that they have a mean of 89 for their grades. Let's find the mean absolute deviation for this student, for their grades. So when we've already got the mean of 89, now we're going to go through and we're going to subtract, find the difference between each of the pieces of data and 89. So, for example, 89 minus 83 is 6. 89 minus 85 is 4. 89 minus 85 again is 4. 89 minus 87 is 2. 95 minus 89 is 6. And 99 minus 89 is 10. So now let me take all of my differences, which are going to be the 6, the 4, the 4, the 2, the 6, and the 10. If I add all of those together, I'm going to get a sum of 32. And 32 divided by 6, because there's 6 pieces of data there, is 5 1/3. So my mean absolute deviation for student number 1 is 5 1/3. On average, that student's grades are 5 1/3 points away from their mean. All right, looking at another student. This student was a lot different in the sense that this student had one grade that was a 0. So let's look and see how that impacts our mean absolute deviation. So our mean in this case was 78. Well, 78 minus 0 is 78. 87 minus 78 is 9. 87 minus 78 is 9. 89 minus 78 is 11. 93 minus 78 is 15. 93 minus 78 is 15. And 97 minus 78 is 19. So now I'm going to add all of those numbers together. I'm going to add together 78, 9, 9, 11, 15, 15, and 19. When I add all of those together, I'm going to get 156. So that's the total deviation from the mean. So if I added together how far away each of those pieces of data is from the mean, I'm going to get 156. Now when I find the mean of those distances, 156 divided by 7 is approximately 22 and 29 hundredths points. What that means is each piece of data is approximately 22 points away from the mean. And the reason that's important is because that shows that there's a lot more variability in student number 2's grades. So if all you told me were the mean and the MAD for each of those students, I would know that student number 2 had to have had to have at least one number that was an outlier in the set of data, probably, because otherwise you're not going to have such a large MAD compared to what the other scores are. So knowing the variability of the data can be really helpful in understanding the mean better. It's a way to help you interpret how reliable the mean is. For student number 2, that mean of a 78 is not really a great descriptor of how well that student's actually doing, and I would know that because there's such a large mean absolute deviation. And so that's how mean absolute deviation and other measures of variability as well, but today we're just talking about mean absolute deviation. That's a way that measures of variability, mean absolute deviation in particular, can be helpful when interpreting a mean.